Hi, welcome back. So let's jump into 3.7. Here we're going to talk about curve sketching. So the objective is to analyze the graph of the function. We're going to summarize curve sketching techniques, and so let's jump in. So we have been learning how we can understand the behavior of a function based on its first and second derivative. While we have been treating the properties of a function separately, such as increasing and decreasing versus concave up and concave down, etc., here we're actually going to combine them here and to produce an accurate graph of the function without actually plotting too many extraneous points. But why bother? Graphing utilities are very accessible, whether on a computer, handheld calculator, or a smartphone. So these resources are usually very fast and accurate, so we will see that our method is not particularly fast. It will require time, but it's not hard. So again, why bother? What we actually are attempting here is to understand the behavior of the function f based on the information given by its derivatives. While all the function's derivatives relay particular information about it, it turns out that the most of the behavior we can care is explained by the first derivative and the second derivative of f. Understanding the interactions between the graph of f prime, and f double prime is very important. To gain this understanding, one might argue that all that is needed is to look at lots of graphs. This is true to a point, but it's somewhat similar to saying that one understands how an engine works after looking over lots of pictures. It is true to the basic idea, but if we go beyond this, a hands-on process will actually increase our understanding further than just looking at pictures. So what we're going to do here in the next table, we're going to summarize key ideas that we have learned so far in this chapter that we can apply to help us sketch the graph of the function. And it gives us a framework for putting that information together. It is followed by several examples in the next videos. So curve sketching, what are we looking for? And I want to say that every function is different. So there's so many functions that won't require that won't have, for example, a critical value or point of inflection, right? So or a vertical asymptote, right? So every function is going to be different, and so we're going to be trying to find the proper information that's needed. So let's jump in with finding the domain of f. Generally, we assume that domain is the entire real line. So remember that domain is the set of all x values that you can input into the function, and the output is a real number. So we're going to assume that the domain is all real numbers, and then find any restrictions, such as where the denominator is 0 or where the negatives appear under a radical. To find the critical values of f, we'll set the first derivative equal to 0 and solve for x, and also find where the first derivative is undefined and solve for x. Find the possible points of inflection, and that's very similar to the previous one, but in this case we'll deal with the second derivative, set equal to 0, solve for x, find the second derivative, and find out where the values of x where makes the second derivative be undefined. Find the locations of any vertical asymptotes, and usually done in conjunction with the item above on number 1. We're also going to consider the endpoints of the end behavior of the function by finding sort of the horizontal asymptote. And then we also create a number line that includes all critical points, possible points of inflection, and locations of vertical asymptotes. And for each interval created, determine whether f is increasing or decreasing, concave up, concave down. And then lastly, evaluate f at each critical point and possible points of inflection. This will give us points in the graph. So we're going to plot these points on a set of axes, and then connect these points with the curves exhibited by the proper concavity. So, and then we're going to sketch the asymptotes at x and the y-intercepts where applicable.